Suppose we have two masses that are going to move in the horizontal, and they are connected by a string. 20 Newton force is applied to the 15 kilogram mass, and the direction of the force is to the right as in the picture, and it's going to cause the masses to accelerate to the right. We'll assume that the string is kind of a perfect sort of string, that it has no mass itself, and it doesn't stretch during the dynamic process. If it doesn't stretch, then we can be sure that the 15 kilogram mass, if it's moving with an acceleration, let's say a sub x, and while we're at it, we'll let to the right be the positive direction, then the 8 kilogram mass is going to have to move with exactly the same acceleration. Their speeds have to be the same, their accelerations have to be the same. Experiments also show that with this idealized sort of string, the force that the string applies to each mass will be the same. The same in magnitude, opposite in directions. We don't know what the tension is. That's one of the quantities we want to find in addition to the acceleration. This really is just Newton's third law showing up, that we have two interacting objects, and the force that one object applies to the other will be equal but opposite the force the other object applies to the one. Now we're going to do the net force equals the mass times the acceleration for each of these masses. For the 15 kilogram mass, net force equals mass times acceleration. Well, in the positive direction, there's a 20 Newton force. In the negative direction, there's a force of t. T is a positive number, so this really is going to be t plus, or 20 plus the negative of t, or just 20 minus t, equals the mass times its acceleration. For the 8 kilogram mass, the only force acting in the horizontal is t itself, and that's in the positive direction. So the t is going to be the mass, 8 kilograms times the acceleration, a sub x. Here we have two equations, two unknowns, using a simple substitution or linear combinations, or however you wish to work the problem. You might want to take the time to verify that the acceleration is going to be 0.86956 meters per second squared, and the tension is going to be about 6.9565 newtons.